All right, so we're going to be moving on here. We're actually going to be looking at the quotient property. So quotient means divide. So we're going to be looking at bases with exponents being divided. Okay, we've looked at the product rule, we've looked at the power rule, and then this one is the quotient rule. Okay, so remember the product rule, you add the exponents. The power rule, you multiply the exponents. Think about it and take a guess right now. Think about it to yourself. Remember that we want to be active note takers. What do you think is going to happen to the exponents when you're dividing using the quotient rule? Okay, and I thought this was funny. They're exponents. So the student asked, why did they quit being opponents? Huh? All right. So let's look at dividing monomials, okay? So you guys have your guided notes. So let's say we have 2 to the 7th, and we are dividing 2 to the 4th. Well, let's expand it. So that means we have 7 2's, and then we have 4 2's. Okay, so anytime there's a 2 divided by a 2, it reduces out to 1. So we can sort of cancel them out. I mean, they're becoming 1. They're not necessarily canceling. But don't worry about it, because if it's a 1, it's being multiplied. It doesn't change it. So we can say we're canceling. So reduce out, reduce out, reduce out. So we have a 1 in the denominator, and we have 1, 2, 3 2's on top, which, of course, if we have a 1 in the denominator, we just ignore it. And then multiply it out. Really, that's just 2 cubed, right? That's 2 cubed, which becomes, of course, if we were continuing, we would make it 8. Okay. Now think about this. Okay, what's the rule here? How did this happen? How did we get from 2 to the 7th over 2 to the 4th and it become 2 to the 3rd? What do you think the shortcut is? What is that shortcut from here to here? What's the pattern? And let's see if that pattern works here for a different problem. Okay, so I have 6 y's and I have 2 y's. So 2 y's will cancel out on the top and bottom, which leaves me with 4 y's. Okay, so did that pattern, that rule that you sort of thought about to get from here to here, did it work? Did it give you the correct answer from there to there? Okay, and hopefully you guys were able to see that all you do is just subtract the exponents, because they're going to cancel out. So you just subtract them. Okay, so our quotient property says that if you're dividing two powers with the same base, you subtract the exponents. And of course, they have to be the same base. So like if this was an x and a y, there's nothing you could do. You would just leave it alone. Okay, so let's say we have a base a to the m divided by a base a to the p. Well, the rule is to keep the base and subtract the exponents. So a more concrete example, if we have x to the 12th and we are dividing by x, well, we would just take 1x away, or we keep the base, subtract the exponent, 12 minus 1, it's always top minus bottom, and we end up with x to the 11th power. Okay, so the quotient rule says we subtract the exponents. Okay, so think about that and let's determine who is correct. Is Jimmy, is Carmen, or is Albert correct here? Jimmy, Carmen, or Albert? Okay, Jimmy's wrong. Why is Jimmy wrong? Because he didn't keep the base. And I see students that want to do this all the time. Hey, if there was no exponents here, 4 divided by 4, sure, that's 1. But because there's exponents, in order to condense them, you keep the base and subtract the exponents. Carmen here, Well, she did keep the base. Boom, she got a 4. But wait a minute. 4 minus 2 is not 6. 4 plus 2 is... she used the product rule and added the exponents. No, 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 no. Can't do that. We need to subtract the exponents. 4 minus 2 is 2. So Albert did it correctly. Okay, so let's look at some examples here. So now these are a little bit different because now there's just not one base divided by one base. We have two different bases, but the thing is we just go ahead and combine the bases that are the same. Okay, so like g to the third divided by g. Okay, so I'm going to go ahead and separate them. All right, just so I know which ones go where. I'm not saying like you have to take this step, but those of you who get confused, you could definitely do that, kind of separate them. So now I look here, I have g to the third divided by g. I'm going to do it the same way where I keep the base and subtract the exponents. So that's going to be 3 minus 1. And then I have an h to the fifth divided by h squared, which is keep the base, subtract the exponents, which is going to give me g squared times h cubed. You don't need to put the dot there for multiplication. You can if you want, but if they're touching each other, it's implied that there's multiplication. So you don't necessarily have to. Okay, so make sure you guys are actually writing this down and doing this part. Okay, I know a lot of you want to use that text box and use the f of x notation, but just draw it in. Draw it in with your finger, or if you have a stylus. Okay, so that's as far as we go. The g and the h's don't have the same base, so we do not put them together. They do not go together. All right, so take a minute, maybe 2 minutes, and try these. Okay, this one's a little extensive because there's 3, but just follow the pattern that we did. Follow what you're doing on A, and just extend it to another base. Okay, so pause it and try it. Okay, so I'm going to do it the way I did the other ones, where I'm going to separate the bases that are the same, and that way I know what's what, I know what's going on. Okay, so I'm going to go ahead and keep the base, subtract the exponent, keep the base, subtract the exponents. Don't forget there's a hidden 1 there. That's why it's 4 minus 1. So I've got x to the first times y to the third. But remember, anything that has a 1 exponent, just like here, there's a hidden 1 exponent, you don't write the 1. Just write it as xy cubed. You don't need the 1 there. It's implied, because if there's an x, well, of course there's 1x. So you don't have to write it. Okay, let's do the same thing here, but we have 3 different variables. We've got k, we've got m, and we've got p. Okay? So I'm going to go ahead and keep the base and subtract, keep the base and subtract, keep the base and subtract. Okay, so 2 minus 2. So I get k to the second, m to the seventh, and then p to the 0. Now this is a special case, this p to the 0. Okay, anything to a 0 power is 1. So basically, instead of going, p to the 2 minus 2, all right, what I should have done is cancel them out. Just if they're the same, just cancel them out, because like p squared over p squared, you could just cancel them out, and then you don't need this afterwards. You just don't even write it, because this is gonna just go away anyways, because it becomes a 1, and 1 times anything is just itself. So you don't need that 1. Okay, so let's see if I can. I think Control P. Yeah, Control P here. So if I was to If I was really doing this problem, let me back up. If I was doing it, I would see this even before that, and I would cancel it out. I would just cancel these out. And then you wouldn't have this, and then you just worry about those. Okay, so it's better. If they're the same top and bottom, just cancel them out. I mean, they reduce out to 1. I know you guys understand cancel out more, but technically you're not canceling it. Okay. Let's see, how do I go back? All right. So we end up with k squared m to the 7th. You don't need to drag that 1 along with you the whole way. Okay, we could have just canceled it out at the beginning. All right, so hopefully you guys were able to take the time and get them right. Okay, if not, just take a look at it and try to make the connections. Okay, I mean, that's active note taking as well. Hey, I got it wrong. What did I do wrong? Well, let's take a look. Oh, maybe I tried to combine the k and the m, even though they're different bases. And I talked about how you can't do that. Okay, maybe you're adding the exponents, but that's only when you're multiplying bases with exponents. This is now the quotient rule. Okay, so we are subtracting the exponents there. All right. So I think that's it. Yep, because there's the assignment. Let me stop this.